and we are here to talk about.
You have to be audible.
We are here to talk about functions and variables. So first of all, we're going to the meaning of function. What's a function? Now, a function is like a mathematical machine or a relation that imputes or, I should say, takes in x values and outputs. This is best work on them and then output f of x value which is also called y values. So, for instance, now that relation is mostly a formula, and you can see our f of x, which is the particular relation. Let me just first of all just mark it. So, something like this, f of x, and then the two box.
Be audible.
So the numbers are usually this is the relation. This is the relation. It takes in the numbers, and then once it has worked on these numbers, it produces output values are the f of x values, and I also said it can call y values as well. So now this relation now, this particular relation, it is not really just like this. They will give you something like a formula. Let's just say f of x is equal to 2x plus 5. This is now a particular machine that is going to work on the numbers. For instance, now let's just say our x values ranges from minus 2
You don't need to solve anything. Just go ahead.
most of the things. Let's say these values now will have to go into this place. These are the input values. Then this is the function. The function will drag these values. And once it collects these values, it works on them. Each of them will have a separate outcome. Minus 2 has its own outcome. Minus 1 has its own outcome. 0 has its own outcome. And just like that until we get back to this 2. And once it's there, then that particular function has ended. And then we go into something called domain and range. These particular values that are here, the x values are called the domain values, and then everything that this particular value here are built to, like their work, like once you work on them, each of them will bring out separate values on their own. Now that kind of thing is called the relation. Is that relate x values to the f of x values. For instance, now let's just say we have A, B, and C. And A now, after A is put in this function, it produces 1. After B was put in this function, it produced 2. And C put in this function, it produced 3. This is now, according to what I was saying, this is now the domain, this is the range. So for instance now, in this kind of, now that we know that this is a function now I want to see what kind of function is this. Okay, oh, sorry. The kind of interaction they have, that kind of association, what is it? So now in this particular scenario, we say that since A produces 1, and you can mark it like this, B produces 2, you can mark it like this, C produces 3, you can mark it like this. We call this kind of function an injective function. Now, why? Because an injective function needs all the domain values to be mapped out once. So now, even if this place has 4, for instance now, this place has 4 now, this particular thing is still a function in the sense that the injective, domain values are mapped out once. But this thing now is not like, it's not what we need now. We're talking about that now. That's not what we're talking about this. So now, if this is an injective now, there are some other, it means that this particular number entering inside this particular function gives you injective association with the domain and relation.
Okay, thank you very much. Madam, do you agree to what he has said, your leader said? Would you want to say more things about a function being, an association being injective, subjective, and bijective? Can you go there? If I see you talking, use that one on the board and tell me. Just say something concerning injective, bijective, and subjective. If the domain has mapped at once, do you agree to what she just said? Would you want to say something about that injective? That if the domain values are mapped at once, yes? That is injected, yes? According to what she said or what you are saying, yes?
If all domains are mapped out once to the domain, then it is called an injective mapping. So let's enter the subjective mapping.
If all the domain values are mapped at once to the range, then injective mapping. Do you agree to what she said? Yes, you? Go there and tell me. That if all the domain values are mapped at once to the range, that's an injective mapping. You're not talking to me, you're talking to the cow.
An injective mapping is mapped of the domain they want to one correspondence of the domain.
One-to-one correspondence, yes? Talk about subjective. When is the function set of the subjective? I mean, the relation set of the subjective.
Let's say we have here, then D is also.
I want you to go there and tell me when an association, a mingling is said to be subjective. Yes?
Okay. When the relation is said to be subjective is when. Okay, in transaction, we look about the relationship and events because it's going to act as just once. But in the subject, we look at the range. The range must be touched. All the range must be touched.
All the range values must be matched
Must be
for a subjective case. Can you say something about something, the relation being, an association being bijective?
Like a completion of
Yes, Igbo boy. If the domain of the relations are not given, how do you determine the domain? You are not talking to me. Can you hear him? Determined by the values like x, cos, and theta. Yes, you. If a relation is given and the domain values are not provided, how do you determine the domain values?
assume the value starting from
You assume the biggest real number set. That's beautiful. I like that. Come, you. Would you want to say something about a relation being subjective? Can you hear? Yes, you. Lastly, can you say something about the functions, the behavior of the functions that you have seen so far?
in injective, they are mapped out to they are having a one-to-one correspondence. In subjective, in a case like this, if we have two coming out two times, we look to subject. If it is supposed to be mapped out to in this case, then in a bijective,
So if something go to 2 and the another one going to 2, that is when it's subjective. Okay, I will say thank you very much for your participation. Thank you and God bless you. To start? Yes?
Good morning, everyone. We are group 5 and we are here to talk about the functions of a real variable. Now, first of all, what is a function? A function is a rule or relation. I'm talking about a function in mathematics. A function in mathematics is a rule or relation that takes in x values as input and outputs y values. Now, for a function to be said a function, first of all, every x value, which is called the domain, every x value has to be mapped out. So if you have x values and y values, let's say we have 1, 2, 3, and we have 4, 5, 6. And if we have two values that are mapped out, then one of them in this domain is not mapped out, then this is not a function. For it to be a function, every value here must be mapped out once. Now, in functions, there are also different types of relations. which we call the association or the mapping. For the mapping, we can know what a function is. We can know the type of relation a function has by checking the range values. Now, if these range values are mapped out to ones, if all of them are married ones, then it is, if not if all of them, but if the values are married ones, then the function is an injective.
Example, can you draw it?
An example, this is, we can say it's an injective. Why? Because these values are mapped out just once. If they are mapped out to, let's say something like this, if there is anyone that is carrying more than one mapping, then it's not an injective mapping again, because it has more than one mapping for one of the range values. If it is mapped out to like this, we can say it's an injective. Now that's for an injective. For a surjective function, for a surjective mapping rather, if all the values in the range are mapped, then it is a surjective mapping. If this one is like this, and we have these values mapping to this one, and there is one left in this range that is not mapped out to them, this is not surjective. However, it is still injective, but it is not surjective. Now like this, it is surjective because all these values in the range are mapped out to, which makes this a bijective function. Now it is bijective because all these values are mapped out to ones, and then all the values are mapped out to. There is no one that is left, and then there is no one that carries more than one mapping. So this is a bijective function. So we can say a bijective mapping, it's when a function is both injective and surjective. Note, not a combination of injective and surjective, but it is when it is injective and it is still surjective. That is when we say something is bijective. Now we should also note that all functions are relations, but not all relations are functions. The reason is because something can be like this. Something can be like this. It is a function. Because I said earlier that a function, for a function to be a function, all these domain values have to be mapped out just once. So if there is any value that is mapped out twice like this one, then this is not a function. Because it's not mapped out just once, but there is one that is carrying it twice. Even if these other ones have just one, for the fact that this one has been mapped out more than once.
Beautiful,
it's not a
thank you.
function.
My sister, can you say something about it? All that he has said is correct. Okay? When do we say a relation of that type is bijective? First of all, is this a function? Why is it not a function?
Because the domain is mapped out two times.
Beautiful, I like that. She said it's not a function because the domain values are mapped out one time. They are made twice. So that is not a function. Now, what of in a case where all of them are mapped out once, but we are having extra term here? Is that still a subjective relation? It's subjective. If we have, assuming we have this is coming here, this one is coming here, this one is coming here, but we have another one, say D, that is not a map. Now, this one, if we say is subjective, are we correct? I'm talking about subjective. Is it subjective? Why is it not subjective?
One domain, and you cannot take anyone from this domain and add it to it.
What is the condition for this kind of expression to be subjective? Now, my sister, you, Pere, can you, if relations are given, but the domain is not given, what do you do in order for you to have domain? Yes? Just say something. Come outside there. She's looking at me. Is she talking to the class or she is talking?
maximum range.
Look at the people you are talking to.
You assume the maximum range.
You don't know, you didn't read, Mary, you didn't read. Now, can you help that my girlfriend? Yes. If a relation is given and the domain is not given, what do you do?
You assume on the domain is the maximal set of the real number.
Yes, I'm happy for you because you can say something. She's saying that if the domain is not given, that you assume the maximal set, which is the real number set. Now, my girlfriend, you, if we have a function, after plotting a graph, say we have plotted a graph, assuming we have plotted a graph like this, and the outcome is like this. What kind of function is this? Can you give it a name? Come outside and talk to me. Real value variable. What is that? If this is a function, what kind of line is it? What kind of function is this? This is a function, f of x. What kind of function is this? Yes? Yes, you. Can you say something about that? She don't know. Yes? It's an injective line. Yes? Can you say something? She's saying that it's an injective line. Yes? Come outside. Talk to the crowd. That is an injective line. Yes, that boy. After plotting a graph, you choose to have something like this. Can you use a word to describe this kind of line? Yes. Come outside without your card. Yes. Talk to the crowd. It's an injective line. Yes, you. It's a linear function. This boy is saying that after plotting a graph, if you have this, that is the function that gave back to that is a linear function. That's correct. That's a straight line graph. I'm happy for you. Generally, I'm so happy for you because the presenter did very well and some of his clients, despite the fact that some were saying rubbish. For now, I will say thank you very much. Quiet, you have started, yes? Can you be audible?
Good day, everyone. We are group 6.
You are group what?
Group 6.
Group 6, yes?
We are talking about functions of the real variable in calculus. So, a function can be defined as a mathematical machine that takes in x value as an input device and as an input device for itself and output y value as an output device to one to one corresponding. Example. So we have injective mapping, we have subjective mapping and bijective mapping. So this is an injective mapping. For it to be an injective mapping, it must be one-to-one corresponding, and this is the domain and the range. This is a one-to-one corresponding, and it's a relation. Injective mapping. This is an injective mapping. For it to be an injective mapping, it must be one-to-one corresponding. So I'm going to. Sorry, let me go back to this again. For it to be an injective mapping, all the lines, sorry, what to say, all the value in the domain must be mapped at once. So we have this is a subjective mapping.
Yes, thank you very much. You have been saying injective mapping. Now, my friend, can you go there and say something? Because he has given us some diagram here, and you're saying that if this one mapper what is an injective mapping, is it an injective mapping? Now it's subjective. Can you say something about it, please? Can you hear him? They can't hear you. You are not talking to me. Can you please tell us more about what you are saying? They are listening, not me.
And,
Maybe it's because I'm here.
and also, not all interactive mapping, all the values in the domain must be mapped out more to make up an effective mapping. And also, we still also have subjective mapping and mission.
I don't understand what they are saying. Can you go and help them? Please.
For a function to be an objective mapping, it has to be one-to-one correspondence. That means all the values in the domain has to be mapped out towards for it to be an objective mapping. Then we also
For
have-
it to be an injective mapping, all the domain values must map at once.
Yes.
Is she correct? Or she is saying rubbish? Is she correct? She is correct that what? Yes? She is telling you, say yes, and you said yes. Yes, that what? She is saying injective mapping that all the domain values are mapped at once. Say it's an injective mapping. Can you say something about it? You only know how to say yes. Yes, you. Can you say something about it? Because they have not convinced us with anything. He has said that when something maps out, that there is an injective mapping. Can you say something about it? My sister, please, can you help them? Can you help them and say something? Have you not studied those things? You are laughing. You can't say anything in the crowd. This thing is going to YouTube. And you are laughing. You can't say anything and you are laughing. Yes? Say something about what your group have said. I've written down there.
If the way and mapped out is called objective mapping. But when if in a situation where one is left out, that means it's not an objective mapping.
So if one is left out here, that is not an injective mapping. But if one is not left out here, it's an injective mapping. Okay. Is she correct? Can you come and what she has said? Has she said something? Would you want to say something to her? Please?
An objective mapping.
Look at them.
An objective mapping is said to be a function if and only if the main values are mapped out towards one-to-one correspondence. Whereby subjective mapping has to do with where the main values are mapped out towards, even though it's not a one-to-one correspondence. And also, we talk about the bijective mapping. What's a bijective mapping? A bijective mapping is the part whereby the relation is both an objective and subjective mapping.
So you can only say things that maybe you don't know, but I know you are talking something. This type of relation, is it bijective or subjective? It's not a relation. It's not a relation. Okay, it's not a function. Why is it not a function?
Because the way values are mapped out twice.
What is the condition for a function?
A condition for
Yes, you. What's the condition for a function? You. Have you said something?
the condition is when the way are mapped out false.
When is domain and matter? What is domain? You said the condition is when domain and matter. What is domain? Power. Yes, you. Go there. This kind of thing. What can you say something about this diagram that we have? Can you say something you don't get strength?
It's not a function.
It's not a function, yes?
Yeah, because the domain values are mapped out. One of the domain values are mapped out twice. And the
So what's the condition for it to be a function, yes?
condition for it to be a function is that all the domain values will be mapped out.
The condition is that all the domain values must map at once. I like that. Please, can you say something? If a relation is given and the domain is not given, what do you do? An example, if you have f of x is equal to 3x plus 4, where the domain is not explicitly written, then what do you do? And you are asked to determine the domain and the range. Yes?
So assume the value of x.
You assume the value of x, yes?
Maybe if you assume that x is 1, then
You assume that x is 1. What of if x is 0?
so you assume that x is maybe from -1 to 1.
Minus 1 to 1. You assume that. You didn't study the video. Yes, anybody left? Yes? Can you say something about what you have said? If a function is given, this a relation is given, and the domain is not given, and you are asked to determine the domain and the range, what do you do?
That like when the thing is about minus
Can you hear her? Say it.
minus 3 x or x open bracket minus 3 then 3.
Yes, who is left? Thank you very much for having the ability to come out to the podium.
Good day, everyone. This is group 7. We are here to throw more light on function of a ring variable. So we all know that the basics of calculus is function of a real variable. And what is function of a real variable? Function of a real variable is a mathematical machine that takes in x values as its input values and output y values as its output y values in a function of x in a one-to-one correspondence, and yeah, that's it. So moving on, let's assume that our function is like our respiratory system, that the process in which we take in we breathe in oxygen.
We are interested in the mathematical part.
Okay, so we breathe in oxygen and breathe out carbon dioxide. So we can have something like this. So this is our x value, and this is our y value. So the process in which this x value is taken in and gives out y value is called correlation. So moving on, we can have different types of relation. In our what we learned, we have 3 types of relation, or let's say mapping or association. We can have it like this. Okay, so in a situation where we have our domain, this is our domain, this is our range, and we have it in this form. This is called the injective mapping, in which our domain values are mapped out to each specific range value. And yes, and you can also see this injective mapping is called one-to-one mapping. Yes. So moving on to the next type of mapping, we can have something like this, where we have our domain mapped out to a specific range value. So let's say our subjective mapping is said to be this mapping is said to be subjective when the domain values are mapped out once to its range values. However, the range value can be mapped out once or twice. That makes it a subjective mapping. And also, we can have our.
I don't understand what you are saying. Do you agree to what she is step aside?
Function is said to be injective. The function is said to be injective when the range value is mapped out once. When it's mapped out one to the range value that one correspondence. That is called the injective mapping. But when we're talking about the subjective mapping, it's when the domain values are mapped out at the same time, all the range values are also mapped out. Because such a function is called the subjective mapping. But when we're talking about bijective mapping is when the relation is same time subjective and injective. It's when the domain value is mapped as one-to-one correspondent to the range values, injective, and all the range values are also mapped out. So such function is called bijective
Mapped out to where? The mapping out to where?
range value.
You said the range values are also mapped out to where?
The range values are also mapped out. Like, I want to give an example. Like,
Is that one giving not enough? Can you go there and explain what they are trying to say? Because I don't seem to understand.
What they are trying to say is that for a relation for it to be effective mapping, all the elements in the domain must be mapped out first.
For it to be injective, all the
All the
elements in the domain must be mapped out once.
Yes. So if they are, but let me say it like this is a function and it's an executive mapping. For it to be the domain value must be all the elements in the domain value must be mapped out. And for the subjective mapping, like we have something like this, we have something like this, and we have something like this, and we have something like this. This thing is it's an executive mapping. It's a subjective mapping.
Okay, that's a subjective mapping. Beautiful, come here. Can you say something about that? Give her the pen. Continue from there. No, he's saying that that thing is a subjective function. So what do you say about what he has said? Do you agree to what he said? It's not. He's saying that that thing is a subjective mapping. What do you say to that statement? The subjective mapping is the one in which the domain and the range are mapped at once. It's bijective mapping. That one is yes. Give her the this thing. Yes, wait first. Is that all that you have to say? Can you tell us more about what you have learned? Pow. Yes. Can you step aside?
What I'll say about this one is that it doesn't meet the criteria to become a function. What makes a function a function is when
You're not talking to me. Can you hear her?
this does not meet the criteria to become a function. What makes a function is when, because this maps out two times, this is not a function. But for it to be a function, we have to remove this line. Then this one, this 2 is the output of C and B. So here 2 is the output of C and B. This can be a function. And this is subjective function. It doesn't matter that this one.
What kind of association is that? What kind of mingling is that?
This is a subjective and this is mapping.
It's a subjective mapping.
Yes.
What are the elements in the range?
The elements in range is 1,
3. Then that's a subjective mapping. What's the criteria for this kind of association to be subjective?
mapping. All of them will be mapped out.
All of them will be mapped out. So that thing now, what do you say about that?
This one or this one?
I'm talking about this one.
This one.
Yes.
What I'll say about this one, that is a function.
That's a function.
Yes.
What's the condition for it to be a function?
And the condition for it to be a function, it has to be 1 or 2. And this is 1 and this. The whole domain has to be mapped out. Number 1.
The entire domain must be mapped out once. But can we allow an element in the domain to map out 2 times?
Yes, but that is the relation.
If you said all the domain values, which one is the domain? This is the domain. Yes, but you said all the elements must be mapped out. Like as it is here now. Is it also proper that I put it this way, then this one belongs because all the domains are mapped out? Is it a function?
No, but this is not like correct twice.
Then what do we say this kind of expression is a function?
But this is not it's mapped twice.
So what is the condition?
The condition is
Yes, can you go there and tell us? I don't seem to understand what they are saying. Yes.
the condition for it to be a function is when all the domains are mapped out and the range are also mapped out. But this is not the function. This is the type that domains are mapped out twice. So it's mapped out
There's an element in the domain that is mapping out twice. Now, if you have a relation and the domain is not given, and you are asked to determine the domain and the range. Like example, if you have f of x is equal to 2x plus 5, and the domain is not specified, and you are asked to determine the domain and the range of that function, what do? You assume the maximal real number set. Is that what you are saying? Yes. Then what do you do? You have to do something because your friends are looking at you.
But the remaining 4 minutes that I did 40, the remaining 2 to 10 things.
Beautiful. Is there anyone that is here to say something? Yes, come. Can you help your sister? Yes. What is negative infinity to positive infinity? What do you mean by that?
Maximum number. To get the other one, you have to use
The maximum number of the range. I don't understand.
the highest maximum.
The highest maxima, they are all the same. Of the range. I don't understand. It's like you get soup inside, you can't put soap inside. Then what kind of product? The highest maximum number of the range. I don't understand. Can you say something, please, young man? Look at the crowd, let them see your face. Have you said something? No. Can you go and help him, please? Because your boyfriend can't say anything. Please help him. If that function is given and you are asked, in that case, it's clear that the domain is not given. If you are asked to determine the domain and the range of that function, what do? Can you hear her? Now, so if you. For you to determine the domain, you said is negative and 0. Yes? Can you go there and help her? Because your sister said the domain is negative and 0. Yes? I thought somebody is talking. No, just say something. You don't need to write it. The negative x value to positive y value. What is negative x value to positive y value? Can you say something about your negative x value to positive y value? Yes. Can you hear? So what are you writing? Is it the negative x value to positive y value? Negative what? Negative x value to positive y value. To positive y value infinity. Yes, y value to positive. I don't understand. Can you say something? Negative x value to positive infinity. Okay, I will say thank you and thank you very much. Allow them to settle down. Cover their faces. So, yes.
Good afternoon, everyone. Hi, I am my colleague Sayed to present the topic which is functions of a real variable. So, what is a function? A function in mathematical terms is a rule or relation that take x values into itself and output y values. So, in further explanation, I'll say now output y value, y value. This kind of expression, I would say a function is a mathematical machine that take x value and take xy values into itself and output y value. So I will give one example.
Just stop. Don't give the example. Just be talking.
Done. We have
Can you hear it?
as our we have minus 2 minus 1 0 1 as our these are our company. Then we have 1 3 5 7 and 9 as our outputs. Then this is the variable. So we map them like this. We map them like this. So this kind of expression like this, they are one-to-one correspondence associated. Associated. So this kind of expression, you don't want to call it one-to-one mapping, you also call it.
Okay, thank you. I don't seem to understand what you're saying. Please, can you help us? Go there and I don't know what you're saying. Yes?
So,
You use my handkerchief as the duster. You didn't see duster and you use my handkerchief.
first of all, this is a function.
Yes?
First of all, this is a function because of all the domain values are mapped as one. If it was mapped out like something like this, twice, then it will not be function. So let's explain different types of functions. Let's say something like this now is a something like this like a subjective function because of these two values in the domain bracket, they are married to one in range bracket, so it's subjective. But I think it was just like this. I think it was just like all the domain values are mapped out once, but even yet it is mapped out once, it will be injected. But something like this, it
a bijective culture because it's both injective and subjective, so you can call it bijective. And also, all functions are relations, but not all relations are functions. Because let's say something like the relation and it's a function. But if this one goes like this, it's still a relation, but it's not a function. So that's what I'm saying. Then
Can you help us, please? You say that the relation is a function and function is a relation. Can you say something? Now, from the video that you have studied, okay, can you tell us, forget about what you have said, can you tell us what you have learned, yes, as a person? From all that you have studied, can you tell us what you have learned? They can't hear you. See where they
The domain must be mapped out.
We are listening, yes? What have you learned so far? Okay, you didn't learn anything. Please, can you go there and tell us from the videos, forget about what all that they have said, or from the videos, what have you really learned, yes? Can you tell us?
So from the video, in a situation whereby we are not giving our domain and our range, I would have something like this. And we are asked to look for the domain and the range. We assume the maximum set of a real number, which ranges from negative infinity to positive infinity. So in this case, after assuming we test for it, after testing for it,
What are we testing? What are we testing?
we have from negative infinity.
Yes, I agree to what you have said. You have said that we should assume the maximal real number set, yes. But you said we should test. What are we testing?
We impute the maximum set of the real number.
You are not testing again.
We impute them which ranges from the negative 0 to infinity.
Yeah, why are you, okay, you are just imputing.
Okay, to test them so that it won't yield an undefined value or it won't yield a complex number.
Now, look at that expression that you have given. You said f of x is equal to x raised to the power 2. Now, from the domain that you have chosen, negative infinity to positive infinity, will it give us a case where we will have undefined or a case where we will have a complex number?
No, it will give us a case where we have an undefined or a complex number.
What kind of function do you think we will have that will give us a case of undefined? Now, can you tell us the range of that function?
So we have from negative 0 to infinity then for the domain. We have our domain, our x and 0.
And you have put one again. Can you go there and tell us all that you have learned so far? Madam, all that you have learned so far. Can you tell us what you yourself learned? Yes. All that you have done. What you have learned, yes?
From what we have learned so far, all domains must be marked out once to be a function. For it to be a function, it must be marked out once, and this is an injection. I mean injective.
Injection, now nurse you be. Yes.
And this is an injective. Yeah.
Yes, can you help us? She's saying that there is an injection, so I don't want to go there. Now, can you say something? All that you have learned, can you tell us what you have learned? Can you hear? Can you go there and tell us what you have learned here? They are telling us that they have not learned anything, and it's not their fault, yes?
All the domain of mark outward, but if the domain that mark outward is called an injective relation.
If the domain values are marked at once, it's called is an injective relation.
So the story range is an injective relation.
Let me show you something. Do you mean this? A, B. He said all the domain values are this is your domain and this is your range. He said all the domain must matter. So the range, this is the range. Now he said they are using map outwards, they are map outwards now. Okay, to something here. So a one-to-one correspondence. Okay. You said they should not map out, so map out to where?
If the domain is mapped out twice, it's not the function, but it's also a relation. Because the domain must not be mapped out twice. But if the domain is mapped out twice, it's not a function, but it's a relation. But in the case whereby the domain range is mapped out by the domain, two domains are mapped out to two domains are mapped out to a range.
Two domains, where are the domains?
Like,
This one is one domain, this is another domain. These are elements in the domain. Okay, these are values in the domain.
Two of the x values are mapped out to one in the y value.
Yes, my girlfriend, can you tell us, not what she has said, can you tell us what you have learned as a person, yes? Bow. Bow. Yes, give to him. Not what anybody has said. What have you as a person learned from those classes, yes? Him papa tell am make no take you go. You no gree. Him mama tell am make no take ganja. Him papa tell am make no take you go. Him mama tell am make. Thank you very much.
Good afternoon, class. My name is Joseph. Me and my group 9.
You are group what?
Group 9.
Group 9, yes?
We have calculus. Inside calculus, we have function of the real value. Inside, what is function? The function is a mathematical machine that takes A function is a mathematical machine that takes in x value to himself and a y value output in one-on-one corresponded. Thank you. Corresponded. So an example of it, let's do something like this. So for example, we have 2 minus 1, 0, 1, 2. And we have minus 3, minus 1, 1, etc. So if this is domain and this is range. So and this side you can call it an input and this side is an output. So if this domain and maps to this range like this behavior is called injective. So in this way, if this, let's say example like 1 and 0, 2, 1 and 2, let's do like this. This is marked like this way, that is called subjective. In this way, that is called subjective. And
Okay, thank you very much. Now, I want you to look at what he has written here. Can you see this kind of expression here? He's saying that this one is subjective. What do you say to this? That's not a function. Can you say something? What you have learned here?
I learned that we have 3 types of mapping, which is injective, subjective, and bijective. Injective mapping is injective if all the domain values are mapped out in a one-to-one correspondence. And then subjective is when all the range values are mapped out to the domain values. While bijective is when it is injective and subjective. That means they are mapped out one-to-one correspondence.
Can you give us an example of what you are saying?
This is a bijective mapping because it is injective and also subjective, whereby the domains are mapped out and the ranges are also mapped out.
I want you to say so. You've not said anything about what is a function first.
A function is a rule or a relation that takes in
I want you to tell us how that you have learned. Don't just be doing as if you're a rat.
A function is a rule or a relation that takes in x as input and gives out y as output in a one-to-one correspondence. You can also see that a mathematical machine that takes in x as input and gives out y as output. Also, you talked about the vertical line test. You said that in the case whereby they give us a graph, let me say a U graph now. You say we should imagine a vertical line and stick it across, and it must be touching one, like this stick across. But if it's like x now, like x like this, and then this is not a function because you do it like that, touching two like this. So this is a function and it's not a function. And also you also talked about if they ask us to, let me say they ask us to find the range and the domain, we should assume the highest real number set, which is negative infinity and positive. Let me say we're giving something like this, f of x equals to x is minus. So you're going to assume negative infinity and positive infinity. I don't start by saying
I want you to don't be writing many things. If you have this function, the square root of x, and you are asked to determine the domain and the range, what do you do?
you're not going to use negative infinity because if you use negative infinity, it's going to give you a complex number.
What am negative for? Is negative infinity is not that.
He said that we should not use anything, any value.
Oh, you want to put that on my head? I said that.
I was going to use any value that will give us a complex.
Yes. Can you go there and tell us all that you have learned? Yes, it's okay. Just stop. Don't just be drawing. I want you to talk. Tell us what you have learned. Can you hear her?
This is a bijective. This is a bijective. Because all the domains and markers are not in a one-to-one story. And these three, they are all backward. This is a bijective. Then,
Yellow CC, go and tell us what you have learned. Yes?
So we say that a function is a mathematical machine. So a function is a mathematical machine that imputes its x values.
Can you hear her?
A function is a mathematical machine.
Yes, can you go there and tell us what you have learned? We know that it's a mathematical machine. Yes?
Good morning. Good afternoon, everyone. Yeah, I'll start.
Over there. Yes, can you go and tell us what you have learned? Can you hear her?
then bijective. When the domain is not part of the domain is not part of the domain.
Can you talk to human beings, please?
What I've learned so far
What you have learned so far, you are looking at somebody's mouth. And he's telling you talk. Yes, talk. Yes, tell us. Quiet. Yes. Injective value can be subjective. Are you a human being? Remove your hands now. You wear trousers away big past you. You stand there. Talk, yes? Can you hear him? Yes, you. Can you hear him? Yes, give to him. Just say something, don't worry.
First of all, a function is a mathematical machine that takes in x value and brings out y values as output. The function is the rule or relation that takes in x value as range and brings out y value as range. And in function, we have three types of relation, which are injective, subjective, and bijective. In an injective relation, the x values are mapped out one-to-one to the y value, which is the domain. The domain is mapped out as a one-to-one relation to the range. This is an example of injective function whereby the domain is mapped out in a one-to-one corresponding to the range value, right? Subjective. The range value is mapped out one-to-one relation to the domain value.
Okay, thank you very much. Thank you. Come out is something. Standing before the people is something. The ability to say something is also something. Now the concern is if you have come out and you can't say anything, then we don't have words to describe you. But for those of you that have come out to say the injective function is, thank God you didn't even put my name. Because you people are even funny set of persons. One was even trying to indict me for what she was saying. She said, you said. But it's okay. I'm happy for you. And I have told you, you're coming out. You talk, you no talk, your attendance is marked. Like those of you that have not entered group, you don't have attendance for this class. Those of you that are in group that have presented, your attendance is on. Now, from our subsequent, in our subsequent classes, we are going to give you out. Now, for the sake of today's class, I will quickly and briefly say one or two things. These are videos that we have uploaded. I'm just here to throw more light so that you can enjoy life. Now, what I want to say today is even and odd functions. Quickly, before I leave.